Welcome to qnawire.
Our question says that a certain radioactive parent nuclei transforms to a daughter nuclei by emitting an electron and a neutrino. So the parent nuclei was at rest. So since it's at rest, its initial momentum is 0. And at the origin of an XY coordinate system. So X is going to be the I hat direction and Y is the J hat direction. The electron moves away from the origin with linear momentum, which I write here, P sub E, is equal to minus 1.2 times 10 to the minus 22 kilograms times meter per second in the I hat direction. The neutrino moves away from the origin with P sub nu, P sub nu of minus 6.4 times 10 to the minus 23 kilograms per meter per second in the J hat direction. So this question wants us to find A, the magnitude, and then B, the direction of the linear momentum of the daughter nuclei if the daughter nuclei has a mass 5.8 times 10 to the minus 26 kilograms. For part C, it wants us to find the kinetic energy. Okay, so first we're going to use conservation momentum. So you have the momentum of the parent nuclei, P sub P, is equal to the momentum of the electron plus the momentum of the neutrino plus the momentum of the daughter nuclei. And these are also all vectors. Okay, well, we said that the parent nuclei has an initial momentum of 0 since it's at rest. So the daughter nuclei, P sub D, is going to be equal to minus P sub E minus P sub mu. Okay, so you plug those values in here, and this comes out to be 1.2 times 10 to the minus 22 in the I hat plus 6.4 times 10 to the 23 minus 23 in the J hat. And both of these have units of kilograms times meters per second. So we can write that on the outside. Okay, but for part A, we're asked to find the magnitude. So we can use Pythagorean theorem here, and treating this as a right triangle. The magnitude then is going to be equal to the square root of the sum of the squares of both sides. So it's going to be P sub E squared plus P sub mu squared. And we can erase some of this. We don't need it to be that long. Okay, so if we plug in the values of P sub E and P sub mu, this comes out to equal 1.4 times 10 to the minus 23. And units, of course, are kilograms times meters per second. We can box that in as our solution to part A. Part B wants us to find the angle, but since as we just established, this is a right triangle, the angle then is going to be tangent theta is equal to opposite over adjacent. So theta is going to equal the inverse tangent of opposite over adjacent, which is P sub mu over P sub E. And this comes out to equal, if you take the inverse tangent of that ratio, this comes out to equal 28 degrees. We can box it in as our solution to part B. Part C wants us to find the kinetic energy. Well, kinetic energy is equal to 1/2 mv squared, right? But we don't know V, right? But we do know mv, because mv is momentum, and we know the momentum and we know the mass. So if we can put this in terms of momentum, we can actually solve this. So if we just multiply this by m over m, this is going to be m squared v squared over 2m, which would just be p squared over 2m. Okay, well, if you plug in the value for m that we were given, which is 5.8 times 10 to the minus 26 kilograms, and you plug in the value of p sub d, we'll use, because this is the momentum of the daughter nuclei, this comes out to equal 1.6 times 10 to the minus 19, and units of energy is joules. We can box that in as our solution. Let's redo that.